Hello and welcome to Mitsubishi Electric Webinars. My name is John Harity and I work within the marketing group here at MEAU. The following Application Solutions webinar will cover high-speed multi-axis feeder applications, where we will take a look at how Mitsubishi Electric's factory automation products can be used to create a powerful solution. First, let's examine how a multi-axis feeder application works. The term multi-axis refers to more than one feeder that is attached to a sorting conveyor. Material is fed piece by piece onto the sorting conveyor to be continuously inserted into cases or envelopes. Since the position of each collated stack must be inserted accurately into each envelope, a master encoder is connected to the unloading conveyor. Each of the slave servo axes on the machine can then be directly linked to the position of the final product. This relationship is important in order to ensure a smooth transition from one conveyor to the next. High-speed feeder machines in the material handling industry can be used in a variety of applications, such as those for stationary packaging, cardstock packaging, bulk mail production, or for collating paper for printing. Using Mitsubishi Electric products, the core component for a multi-axis high-speed feeder application is the MRJ3 series servo amplifiers. As shown below on the bottom right, 4 servo amplifiers are connected to an IQ platform motion controller, the Q173D CPU. Depending on the type of machine, the servos are capable of producing anywhere from 12,000 to 24,000 pieces per hour, which equates to speeds of up to almost 7 pieces per second. Each servo is commanded to move based on command pulses from the master encoder. The master encoder is connected to the unloading conveyor, which is controlled by an FR-E700 inverter via a CC-Link network. A special networking card, the FR-A7NC, is used here to communicate with the CC-Link master module in the PLC rack. The PLC rack contains a Q04 UDEH programmable logic controller that continuously communicates to the motion controller and the CC-Link master module. Using IQ platform technology, the PLC CPU and motion CPU share information across a high-speed backplane bus. This bus supports bidirectional data transfer of up to 14,000 words of data in less than 1 millisecond. This provides a huge advantage for demanding applications where the motion controller must receive updated information very quickly in order to feed at the right times. Other modules you see in the rack include standard digital input and output modules, along with a module dedicated to reading feedback from the incremental master encoder. This is the Q173DPX you see in the last configured slot on the IQ platform rack. Another key product to this solution is the Mitsubishi GOT that is connected to the Q04 UDEH PLC CPU. The graphic operator terminal provides complete control of the system and includes built-in functions for diagnostic monitoring and troubleshooting. All of Mitsubishi's application solutions provide benefit in terms of increased performance, quality, and total cost of ownership for machine builders. For the multi-axis feeder solution here, 3 particular features stand out that make Mitsubishi Electric's solution particularly valuable. The first highlight is the IQ Platform multi-CPU system. With IQ Platform CPU processing speeds, throughput for a multi-axis feeder system is greatly improved. The second highlight included in the solution is the ability to synchronize all the feeder axes. With full synchronization, the operator avoids damaging the product during insertion. A fast resynchronization routine allows the operator to get the machine up and running quickly, avoiding excessive machine downtime. The third feature of this solution to bring added value to a customer is the flexibility of Mitsubishi Electric's HMI interface. Built-in troubleshooting functions reduce maintenance delays and engineering costs. With recipe storage, a multi-axis feeder machine can easily be loaded to run with different sized materials, for example. The communication options on the terminal also allow the system to talk with other components for data logging, remote maintenance, or even for surveillance purposes. When breaking down this application to understand what's happening behind the scenes, the best place to start is the layout of the mechanical editor. The following combination of electronic clutches, gears, and cams is what makes up this high-speed multi-axis feeder solution. First, let's look at the drive module, or the master encoder, which is the main point of control for all 4 servo axes. When the unloading conveyor is driven by the VFD, The incremental encoder or master encoder provides pulses to the system. When the clutches are closed, all 4 slave servo axes move. The inserter axis on the far left uses a complex cam profile to carefully insert material into each of the envelopes or cases. The sorter and feeder axes move with constant speed feed cams. If additional feeders are needed for a machine, they can easily be added to the system layout to the right. One particular